mean, I started talking a little bit about the fats, but the biggest problem I see in our part of the country, culture-wise, food-wise, besides getting poisoned, like you're talking about. It's bad enough to get poisoned, but you have to protect the cell membrane. And that cell membrane is a fatty lipid sandwich, is what it is. And that fatty lipid sandwich is comprised of a very specific ratio of omega-6 and omega-3 fats, predominantly, which give it elasticity and permeability that allow the transport proteins, which are the openings in the cell membrane, to dump the junk and also take in the nutrients. So if the cell membrane becomes rigid because you're eating all this fryer fat, which is omega-6 damaged, oxidized omega-6s, and also the cell membrane, by the way, is an oxygen magnet because these polyunsaturated fats that are in the diet are very, very susceptible to rancidity. And the reason why they don't go rancid in a healthy body is because there are enzymes called superoxide dismutase, SOD, and other enzymes that are built upon trace minerals like zinc, copper, and manganese. And they act as preservatives to keep that fatty lipid sandwich from going rancid in the body. Well, if you're eating rancid fats, which most of us are, because they're in all the restaurant fats, nobody cooks with good fats. It's hard to get good fats if you eat out. If you eat in, you have to cook with your favorite oil here, coconut oil. And you need to eat sources of other fats. And if you don't eat the fish, then you need to eat things like grass-fed eggs. And you need a raw milk industry in Hawaii, grass-fed raw milk industry, because the raw milk is loaded with the omega-3s. And again, what you find out is that the omega-6s come with it, but they're balanced. If you get omega-6, omega-3 fats in grass-fed beef, it's about a 1-to-1 ratio, sometimes a 2-to-1 ratio. That's good. But the American body fat is up to 20 parts to 1 omega-6 to omega-3. And this is completely out of whack. It should be somewhere in the neighborhood of around 2.5 to 1. So you don't get all this inflammatory processes and that the cell membrane stays flexible, permeable, and attracts oxygen. Remember, healthy cells. And Otto Warburg was the guy who got the Nobel Prize on cancer doing the work he did in the 1920s, got the Nobel Prize, I think it was in 1932, showing that cell respiration, which is burning oxygen or burning glucose with adequate amounts of oxygen inside the cell, just like a prime furnace, is the reason why we get so much cancer. And now, because the cell membrane is so damaged, the oxygen's not getting in there. When the oxygen levels drop about 30 to 35% inside the cell, you have lactofermentation of the glucose instead of high oxidation of the glucose. That's cancer, according to Warburg. And they're revisiting Warburg now. They're saying, yeah, he was right. He was right. And then in the meantime, the cell membrane gets damaged with all the metals. I saw, when I came back from Australia like 5 years ago, I stopped in LA, picked up the LA Times at the airport. Front page article in the LA Times was the entire research they were doing in the Arctic Circle about all those people that were dumping all of our heavy metals on up there. The Inuit that are living in Greenland and Siberia and Alaska, people that are still living native diets. And these are people that eat a high-fat diet. They eat a lot of fish, they eat a lot of blubber. What they were astounded by was the huge amount of heavy metal intake that they were getting from us, the industrial Europeans and the industrial North Americans. All of our waste goes north, comes down in precipitation on those people, and they're eating cadmium and lead and mercury at high concentrations. And what was astounding to the researchers was they're not as sick as we are with a lot less metals. And the reason why is because the tremendous amount of fat that they eat. So you got to circle the wagons, You got to get rid of the junk, like she's talking about, but you got to protect the fort. You got to get the good fat in there to protect that cell membrane, because that's what we are. What are we, 50 trillion cells or 100 trillion cells? We're somewhere between the two. Right. We're 50 to trillion cells, and each cell, is running at, 500,000 biochemical reactions per second. So, and you got to have oxygen to run all those biochemical processes. So anyway, I've weighed in on it, I think.